In this video, I'm going to explain about the two-stage commit model in iOS XR. Cisco iOS XR supports the concept of a two-stage commit model. In a single-stage commit model, each line of the configuration that enters the router takes effect immediately, like Cisco iOS. This approach does not scale because the user configuration is applied serially without the provision to apply the configuration in bulk. In addition, while applying the configuration from a file or a script, it is possible for only part of the user intended configuration to take effect due to syntax or transport errors, which leaves the router configuration in an inconsistent state. But in the two-stage commit model of the iOS XR, during the first stage, the user can build a target configuration without affecting the router's configuration or the router's running configuration actually. In this stage, the user can address both syntax and transport errors to ensure that the entire target configuration has entered the router successfully. In the second stage, called the commit stage, the entire target is committed and becomes part of the router running configuration. Because the entire target configuration has entered the system, the committed configuration is carried out in bulk. The two-stage commit process helps in applying the configuration in bulk. This in turn helps in doing subsequent operations such as verification, checkpointing, logging, and so on in bulk. Bulk operation is especially good for performance because it reduces inter-process communication or IPC overload. This figure illustrates the two-stage configuration concept. In the first stage, user or administrator config or change the configuration, but the change of configuration doesn't have any effect on the running config of the router, and after typing commit, the configuration will add or will merge to the running configuration of the router. Actually, the target config equal to the config change that user did plus the running config. This is the merge of these two. But don't forget, when you are in the first stage, actually it means that you config some of the features in the device, but it doesn't have any effect. After commit, you will go to the second stage, and in the second stage, the configuration will go to will add to the running config or configuration database of the router. Because of that, again, let me to emphasize that the target config in the device equal to the config change plus the previous running config. Actually, the target configuration is effectively the cumulative result of the current running configuration with the user entered configuration. In other words, it is the user intended configuration if the user were to commit the entered configuration changes. Each user has its own unique target configuration that is not visible to others. However, the latest router configuration is visible to every user and it forms a base to each user's target configuration instance. A user can populate the target configuration change from a previously saved file and browse or modify configuration change in the target without affecting the current running that is active configuration on the router. The router running configuration can never be set directly. All change to the running configuration must go through the target configuration where it is explicitly committed by the user to become part of the router's running configuration. A unique target configuration is created implicitly when the user enters the configuration mode. The target configuration is not a copy of the running configuration. Instead, it is an overlay of configuration change. entered by the user, which has not been committed yet, on top of the router's running configuration. When the user entered the first stage of the configuration and prior to entering configuration change, the target configuration is identical to the running configuration. Let's start with the clean interface with just, for example, default configuration. Look at here, we can use show interface command or show running config. For example, in show running config, we have this configuration, they are default. I want to see the configuration of only interface gigabit 000. Because of that, let me to use show running config and then interface gigabit 0/0/0/0. As you can see here, now we have this configuration. This is the default configuration of this interface, okay, with show running config. This is the actually running config that now is active in the router. But now I want to configure the, for example, interface with no shutdown command. You know that here we need to go to the global configuration mode and after that to the interface gigabit 0/0/0/0. Now actually the target file or the target config equal to the running config. Okay, and after that let me to use no shutdown command or any other command. You know that this command now it doesn't have any effect because we didn't commit this command, and now you can see this actually the config or change command, or you can see the show configuration. Show configuration means the configuration we did, but now it didn't apply to the running config. Look at here, you can use, for example, show config or configuration. Show configuration can show us that now we have this configuration, but you know that this configuration is not available in the running config. I can show you, for example, show running config again, interface gigabit 0/0/0/0 can show us that here interface gigabit 0/0/0 now is shut down, and the no shutdown command doesn't have any effect. But after committing this command, the no shutdown will replace the shutdown command. And don't forget, if you have one interesting option, this interesting option is that you can see what is happening when you merge the config change with the running config without doing this now. Here we have a nice command. You can use show configuration, okay, show configuration and then merge. And after that, interface gigabit 0/0/0/0. What does it mean? It means that please show config merge, please show me the merge of the config change and running config for interface gigabit 0/0/0/0 without doing it actually. Actually, this is not a practical command. This is only for your understanding. Show configuration merge interface gigabit 0/0. Look at here. After merging, here the interface doesn't have the shutdown command, and because the no shutdown is the default, here we don't see the no shutdown command, but actually now the no shutdown command work and the interface will be up. Because of that, now we know about these three commands. First, with show configuration, you can see the config change. With show running config, you can see the running config. With show configuration merge, okay, let me to show you show configuration merge without the interface. You can see the merge of config change and running config without doing it, okay? Because of that, now we can better understand what is happening. Actually, a unique target configuration, okay, is created implicitly when the user enters the configuration mode. For example, you go to the config with you go to the global config mode with the conft. Okay, the target configuration is not a copy of the running configuration. It is instead an overlay of configuration change entered by the user, which have not been committed yet, on top of the router's running configuration. When the user enters the first stage of the configuration and prior to entering configuration change, the target configuration is identical to the running configuration. Yes. And after that, this is also the case after each successful commit operation. For example, after committing the configuration, again, the target config and running config are same. Okay, but when you go to the, for example, interface mode and configure no shutdown, now we have difference between the target config and also the running config, because the target config is equal to the config change plus running config. Okay, and after that, the user can browse the configuration change mode here, the configuration change mode in the current session, but not yet promoted to the active configuration by using the show configuration I showed you. And the user can also browse the resultant configuration produced via the merger of uncommitted configuration and the router's active, also known as running configuration, by using the show config merge I showed you again. This is essentially the session's target configuration. And now we can better understand about the config change, how we can monitor it with show configuration, about the running config, how we can monitor it with the show running config. And also we know that if you want to see the result of config change to the running config, adding config change to the running config without commit, we can use show configuration merge command. Alright, now let me to explain about the commit operation. About the commit operation, commit is the operation through which the target configuration is committed to create the new running configuration, as you can see in this figure. Okay, target config and then commit. Now this configuration will go to the actually the configuration of device or running configuration. Target config now is available here. Okay, and also by default the commit operation is pseudo-atomic. In other words, the commit operation could fail for semantics and only valid changes are allowed to get committed. The following event take place for every successful commit operation. First, before committing, it must first lock the configuration session. And after that, in the step 2, saves the configuration change in the commit change database, creating a rollback point. And step 3, adds a commit change entry to the configuration history. And then step 4, generate a config change notification using syslog. I will show you. And step 5, target configuration is integrated into the running config at the end of successful commit operation. And step 6, unlocks the configuration session. Each time a new configuration is built and committed, Cisco IOS XR adds a commit change entry to the configuration history and generate a configuration change notification using syslog. Alright, now let me to show you the configuration log notification during commit. Here you can use, for example, configure command. I want to go to the next mode, global configuration mode, and after that here I want to use the host name R1. As you can see now the host name is iOS. Let me to use host name R1, and you know that this command doesn't have any effect because this command now is residing in the configuration change, and here you can use show configuration, and in show configuration you will see that we have this configuration. And also in the running configuration, show running config, this command is not available. Host name is iOS. Why? Because we didn't commit it. Let me to commit this command, and here after some second you will see that the command committed, because now here we can see the host name changed, and also here you can see a log. Okay, and especially you can see a number in show configuration commit change this number. Okay, and actually by default the commit operation assign a unique change ID. This is the change ID, allowing you to view the detail of the point commit. Okay, in this example this number, okay, this number is the commit ID assigned for the configuration change that went in the last commit. This commit ID is also helpful to quickly verify the change that went in a specific commit operation. as you can see here, we can use the show configuration command. Let me to use this command, show configuration commit change, and then the num or the actually commit ID. Okay, this is the change ID, commit change ID. Look at here, this is our command. When you press enter, look at here, after pressing enter, it says you that this configuration change in with this commit ID. Actually, this example, with this example, you can use the show configuration commit change, then commit change ID command to view the committed change. Okay, it is interesting. And also, the target configuration can be committed using either pseudo-atomic or best effort options. In the case of commit with the pseudo-atomic option, the entire configuration in the target area is committed, the entire configuration. In case of any verification error, the commit operation is rolled back and the errors are returned to the configuration agent. Okay, in the case of commit with the best effort option, only the part of configuration that has gone through successful verification gets committed and not necessarily everything in the target buffer. In this case, the errors are returned to the configuration agent. Okay, let me to show you, it is interesting. Now here, for example, I want to use host name R2. Okay, this is a correct configuration. And also, for example, interface gigabit 0000, and here I want to use IP address. Okay, you know that we should use the IPv4 address. Let me to use IPv4 address. And after that, for example, quad 1 and then quad 1/24. You know that here this IP address is valid, but we can use some invalid IP address or some invalid, for example, value. For example, 11110. Okay, because you know that this is the network ID. Okay, /24. You know that this is not correct. This is the network ID, not the host address. And after pressing enter, now I'm going to use commit command again. This is the show configuration. Now we have this configuration, and I'm going to enter this configuration. For example, commit. Okay, here, as you can see, failed to commit one or more configuration items during a pseudo-atomic operation. In pseudo-atomic operation, as I mentioned before, the entire configuration in the target area is committed. In case of any verification error, the commit operation is rolled back and the errors are returned to the configuration agent. Because of that, as you can see, now the R2 doesn't have, the R1 doesn't change to R2. Actually, none of the commands, for example, permitted. But we can use the next mode of commit. We call it commit best effort. In commit best effort, I will show you only the part of the target configuration that has gone through successful verifications gets committed, and not necessarily everything in the target buffer. In this case, the errors are returned to the configuration agent. Okay, let me to show you here how we can change it. We have option of commit. Okay, and then the question mark. Look at here. Here we have many options. For example, best effort. Commit the configuration change via best effort operation. And also, for example, we have other options. Let me to use, this is the default is commit with the pseudo-atomic operation, because we use only commit command. Okay, now I want to use the commit best effort command, and also here this is the I want first to show you the running configuration. Actually, show configuration. Here now we have this invalid command. Okay, and after that, let me to use this command commit and then best effort. Look at here. Unexpected argument in commit string. As you can see here, now we have this error message. It's okay, but the correct command now run and permitted. What does it mean? It means that when you have some valid command and some invalid command. Valid commands are permitted and not invalid command are not permitted, and here you can see the error message. This is the difference between the pseudo atomic commit, this is the default commit, okay, and also best effort commit. Also, during a commit operation, configuration manager implicitly locks the configuration session to prevent any change to the configuration by any other configuration agents. The router running configuration is unlocked at the end of the commit operation. Not all the options available in a commit operation are discussed here, and you will learn about them in future. And also, let me to show you another example. Actually, this example shows the use of the commit operation with the comment option. Here we have one other option, comment, assign a comment to this commit. Okay, and to add descriptive information to the change, and the label option to assign a name to the point commit. Okay, this option helps the user while doing rollback and for easy recovery. Instead of a number, you can use a name. It's easier. Let me to show you. For example, here I can configure the host name R10. Okay, and now we have this host name show configuration. Look at here. This is the command now we have in the configuration. You can use this command. It's interesting. Commit and then label. You know that here I want to use the commit command. Commit label host name. Okay, look at here. Assign a label to this commit, and also we will assign a comment. Commit label hostname means this is a commit for the hostname configuration that we have in their configuration. And after that, comment, you can use comment, and then here each comment that you want you can use. For example, I changed, okay, the hostname, or any other comment. Okay, look at here, commit label hostname. This is our comment. Now here actually you can press enter, and you can see that now the hostname changed to the R10, and also if you want you can use this command show configuration for verification. Show configuration commit, okay, and then for example list one detail. Look at here, this is our configuration. Commit ID, label is host name, and then for example here you can see the comment, label and comment that we have for this commit. Don't worry about the list number. Now you can use only list one and also you can define other list. In list one we have this with this label, actually this comment with label of host name, and also we have a comment for this label. This is the commit ID, and you remember I used this command show configuration, okay, and then commit change. Let me to show you show configuration commit. For example, here we have two options, commit change, show change mode during a series of commits. For example, you can use show configuration commit, then change, then this ID. Let me to show you first change, and then this ID. Okay, and after that we will see this configuration change, and after that show again a configuration commit, and then here you can use the list, for example in list one, and after that the detail. Look at here we can see this change. Also, we have many other options. Now I'm not going to explain all of them, but now we can better understand about the options of commit, and also in future you will learn more than this. All right, now let me to explain about the commit confirmed option. Okay, the commit confirmed command helps to commit the target configuration on a trial basis and not as a permanent configuration. It's so interesting. A user can provide the amount of time to wait before the configuration rollback to the previous configuration. Okay, commit confirmed is available in global configuration mode. you can configure the amount of time, okay, before rollback, and it can range from second to minute. The commit confirm option is not available in administration configuration mode. Let me to show you, you are changing the host name of the system from the R10, for example, to R11. Let me to show you here. I want to use host name and then, for example, R11. Okay, this is our change. And after that, we changed the host name of the system from from R10 to R11 for 30 seconds. After 30 seconds, the commit roll back to the previous state of the router, means hostname change automatically to the R1 with this command. Look at here, commit and then confirm and then, for example, 30. Okay, after 30 seconds, you will see that the command, now the command committed. Look at here, as you can see now it is R11. After 30 seconds, we expect to see again R10. Actually, a user can provide the amount of time to wait before the configuration rollback to the previous configuration. And commit confirm is available in global configuration mode. And now we wait for about 30 seconds. After 30 seconds, we expect to see that the host name will change to the R10. This is the commit confirm. Look at here. This is the commit confirm. Now the configuration changed to the R10. Okay, so easy. Because of that, now we know about this option. Also, about the commit failures, actually, configuration items that fail to pass semantic verification during commit are known as failed configuration. Now here we have one failed configuration. Look at here. Let me to show you here in the R10 show configuration. Now here we don't have it, but let me to exit and then conf t. Let me to configure interface gigabit 000 with the wrong IP address, IPv4 address. Okay, 10.1.1.0 and then /24, and also let me to use host name R20. Okay, you know that now we have one invalid and one valid configuration. Okay, actually this is the failed configuration after committing show configuration. Look at here, show configuration. Now we have these two commands, host name and IPv4 address. Let me to commit it, commit. Here, as you can see, now we have one failed configuration. This is the failed configuration. If a failed configuration is generated in an atomic commit, this is the atomic commit, you know it, target configuration is left intact. Yes, because as you can see, the host name is R10 again. Okay, and as you know, nothing is promoted to active configuration. In iOS XR, if a commit attempt fails, the failure of the commit can be viewed through show configuration fail command. It's so easy. Okay, let me to show you first. The show configuration failed. Okay, show and then configuration and then failed. Here you can see which command or commands, okay, result the fail. This is the command that now we should correct it. Look at here, IPv4 detected the warning condition invalid host address or mask. Yes, it's okay. Okay, because of that, now we know about the failed configuration. Let me to review it. Configuration items that fail to pass semantic verification during commit are known as failed configuration. If a failed configuration is generated in an atomic commit, target configuration is left intact and nothing is promoted to active configuration. In iOS XR, if a commit attempt fails, the failure of the commit can be viewed through show configuration fail, as you saw in this example. The output of the command can be used to view the reason, as you can see here, okay, and also actually clues for commit failures and correct the mistakes if any. Alright, now let me to explain about the configuration failures during startup. When the system boots up, you might experience some configuration failures. This can typically occur when upgrading or downgrading router from one software release to other. Possible type of configuration failures are syntax error, semantic errors, and apply errors. About the syntax errors. Syntax errors are generated by the parser and indicate that the CLI command is not recognized. This is usually due either to a typo or the fact that the command is not present in the current version of the software. And then semantic errors. Semantic errors are generated by the backend component that verify the startup configuration during boot up. It is up to each backend component owner to analyze the cause of the failure. And finally, apply errors. Apply errors occur when configuration passes the verifier's semantic check and is accepted as part of the running configuration, but the backend component is unable to update its operational state. You can view configuration failure using the show configuration failed startup command. As you can see in this example, show configuration failed startup, and here you can see configuration failed due to a syntax errors NTP HTTP server. Don't worry about the detail. In future, when you work with the real devices, you can better understand about these different types of failures that maybe we experience during startup.